Hello, my name is Jeff Groom. I'm an engineer with Ciena. And when I was in kindergarten, I got an assignment from the teacher, and the teacher had us make a project for Halloween. Put a bunch of paper on all of the desks. And I decided I'm going to make a bat. So I grabbed a piece of paper, grab a black crayon, and I realized I need more crayon because I wanted to make a big bat. Right? So I go up to the teacher and I say, hey, can I have a black crayon? And she says, you have a black crayon in your hand right there. I said, yeah, but I want the whole bat to be black and the paper is white. She said, well, why don't you just use a black piece of paper? And I was like, why didn't I think of that? That seems so obvious. So now I've been in the telecom industry for about 15 years now, and I've noticed a couple things. First is that carriers, they really sell just 4 products, maybe a bit more than that. But in general, they sell layer 1 services, layer 2 services, layer 3 services, and internet. The way that they've been delivering that has evolved. Okay, so about 3 years ago, if we rewind, the way that they did that was all of the vendors, right? So we've got, Ciena's a vendor, and we would have an NMS platform. And we'd have devices. And we'd have another vendor and a third vendor, right? And they've got their NMS and their devices. And we would all give those to the carrier, and the carrier's job was to implement and provision those things into their OSS, BSS platforms. But most important, their role was to test, to make sure that the platforms that they were using and the devices that were used would deliver the layer 1, 2, and 3 services to the customers. So that was 3 years ago. This process here, this took like a year. Today we're in the world of orchestration, and things have changed a bit. So now what we have is an orchestrator, and that orchestrator is really a development platform, right? Ciena's orchestrator is Blueplanet MDSO. And this platform is given to the carriers, and their job is to implement the orchestration and then to test. So here we've gotten these time cycles. They've been reduced to about maybe 3 months, 3 to 6 months, let's say. Here's what's going to happen next. These two things are going to evolve into the same process. And the orchestrator is going to play the role to facilitate that. So what we're going to have is an orchestrator. Same thing, 3 domains. But now what we're going to add is the test capability. So the orchestration platform will perform the function of testing the layer 1, layer 2, layer 3, and internet services. That's going to bring our timelines down to about a day. So in this demo we're about to do here, what we have is an adapter in the orchestration platform. The one we're using is an expert, Veryx. They make a layer 2 MEF 2.0 test set. And it's SAM test is the platform that's used to execute those tests. So this demo is going to show the creation of a service, and the testing of that service using an orchestrator. Then that orchestrator can be taken and rolled right into production, because that's what DevOps is. It's having the lab equal your production environment. So let's get this demo going. Okay. We had to search around a bit to find it, but here it is. This is the black piece of paper. And in this case, a picture is worth 1,000 lines of code. LucidCharts is a simple diagramming service. Here we're going to use it to orchestrate services in Ciena's Blueplanet. First, let's see what we expect this drawing to do. When we click a couple buttons in Blueplanet, the orchestrator is going to read the diagram, extract some data from it, and then execute what the diagram is communicating. If you recall, the most important output is the test result for layer 1, 2, and 3 services. In fact, service testing and test sets are so important that it's very common to attach them to an optical switch. This way, they can be utilized by lots of different components in a lab. So that's what our simplest drawing will do. It's going to tell an optical switch to connect a couple test sets together back to back, and then the drawing will execute a test. So back at our drawing, we've got our 2 probes here. And this line in the middle is the cross connect. The drawing lets us assign metadata over on the right. You'll see some properties for the input port on the cross connect switch and the output port on the cross connect switch, and some other things that help us fill in stuff for the orchestrator. Also on this drawing, we've got our test that we're going to run. And this has the properties for the test. You'll notice this one has an SLA of high metro, which is a MEF parameter. So let's look at what this looks like from the orchestrator from Blueplanet. We're going to take a look at the Lucid diagram and how it gets converted into something that we can execute. So this is what the RA collects. So this is a diagram we were just looking at, and you can see here we've got layers, and we have some resources in each layer. This one is the cross connect, and this is all of the details from the test that we're going to execute.
So here we are going to create the test. So we're going to create, pick our resource type, and we're going to execute a page translator. That's what how we execute the test. So we give it a label, and we pick the page that we want to execute. So we're going to run this back-to-back EPL page from our drawing, and we choose create. So now let's check out the status of what is occurring with that. So it looks like it's building out all the different resources. It created the cross connect on the optical switch, and now it is executing the test. So we're going to open up the test on the SAM test controller, and we can see the real-time status of what that test has. So there's the circuit that was created. You see the MTU stuff just passed, and it looks like the information rate is running. So that's going to run. We're actually expecting this to fail, and it fails because we are giving it more bandwidth than it expects. So it gives us a reason for why it failed, and let's see. Now we can verify that that reason comes through as the error in the orchestrator. So there, the error popped up in the orchestrator, and let's take a look at the resource data, and yep, looks like the maximum transmission unit is greater than expected. So the circuit was allowed more data than it was supposed to have. That's leaving money on the table.
So that's it. Any questions?